systems of equations. That's when you have a equation such as y equals 3x minus 15 and x plus y equals 13. You have two different lines, and a line is a line because it has an x and a y in it. So if you set it up into this form, which is y equals mx plus b, which is our slope-intercept form, this tells you this is the slope, which is m, and b is your intercept. If we made the slope 0, there was no slope, and you took that away, then y would equal b. So if you take this first one and we can graph it, y equals 3x minus 15, I would say if that were 0, y is minus 15. So we're going to say that this point is minus 15. It's 0, it doesn't go anywhere, it's 0 minus 15. And then my slope is 3, which means I'm going to go up 3 over 1. So I would count up 1, 2, 3 over 1, 1, 2, 3. So it would kind of look like this. Use a different color. It would kind of go up 3 over 1, up 3 over 1, up 3 over 1, like that. And you would count it, and then if you place a few dots, you can draw a line. Then we take this other line and we change it by moving things using our equation methods, and we would move the x over. So we would end up with y equals minus x plus 13. We subtract that x from both sides. Now it's in the same format, so we know we have a minus 1 slope. Minus 1 over 1, which means a negative slope goes downhill. Positive slopes go uphill, negative slopes go downhill. If we get rid of this minus x, because we put a 0 in there, our y is equal to 13. So we're going to say that this point is 0, 13. Okay? Now, we then have a one-on-one thing. We go down 1, over 1, down 1, over 1, down 1, over 1. And when we draw the lines and connect the dots, where they cross is the solution. So that's the pictorial way to do it. It was very difficult to do that on this board because it's hard to draw perfect. So if you don't have grid paper, this is probably not a good method, but you may be shown a grid that looks like this, and you know that where they cross, that is their solution. You can figure it out by solving for it too. So if we go to the next page, I said 3x minus 15 was what one y was. Minus x plus 13 was what the other y was, and y equals y. So we can now solve. We move the x's over. 3x plus x is 4x. We move the negative 15 over, so we add it. Plus 13 plus 15 is 28. So this is just your basic equation. So we have 4x equals 28. To solve for x, we divide by 4, and x is 7. Now if we go backwards, we plug 7 into our problem. And we get 3 times 7 is 21. And 21 minus 15 is 6. So y is 6, and x is 7, because we figured that out. And so this is 7, 6, that's the solution spot. And when I did it the first time I did this video, which you will never get to see, it did not come out pretty because I couldn't draw it on this board. But we did use graph paper, and we did prove that it does graph out that way. So I drew the graph in to give you the concept of how it works. But that's what a system of equation is, and that's how you know that you have the right answer, is where they touch. And you solve it by substituting. Make one of them equal y or x, and substitute that in the other problem for y or x. You will then get the answer to one of the letters, which you then plug back in and solve for the other letter. So it's a lot of algebra and a lot of substitution and a lot of replacement, but these are all skills that you have built up to this point. And just so that you understand, when they ask you for a system of equation, you can often take the answers, plug them in, and find out which one makes it true. So they may have given you several pairs. You can say, well, I can plug 7 in to this one, and I get 21 minus 15, and I do get 6, so therefore that is my answer. It should work.